Hi there. If your HPC jobs spend too much time waiting on file reads or writes, then this video is for you. I'm Conrad from the OzSTAR HPC team, and today we'll optimize Lustre I/O using three tools: JOBFS, SquashFS, and Apptainer. By the end, you'll be able to slash your job runtimes and reduce strain on our shared file system. Let's dive in. Firstly, let's talk about why Lustre struggles to deal with lots of small files. It's because every file operation checks with the metadata server, which becomes a bottleneck. When an application repeatedly reads the same files over and over again, that floods the network. Luckily, we have a trio of tools that solves this. The aim is to replace many file operations with a single file operation, or offload I/O from Lustre onto the compute node's local storage. Meet JOBFS. That's your node's lightning-fast local scratch space. It's perfect for temporary files, like intermediate results. Here's how to use it. First, check your JOBFS space using a SLURM job. Here's a minimal script that requests 50 gigabytes of space and prints out the available space. When we submit this, you'll see the available space. Now, here's how we can incorporate this into our workflow. Step 1. Copy the inputs from Lustre to JOBFS. Step 2. Process them locally. Step 3. Save the outputs back to Lustre, like this. As a reminder, JOBFS is ephemeral. That means if your job crashes, the files vanish. So always copy results back. Next up is SquashFS. If your job reads thousands of small files, for example, like machine learning training data, then you want to bundle them into one compressed read-only image. Here's how. First, create a SquashFS image on the login node. Say your data is in your project directory on OZ000. Here's the make SquashFS command. Now, in your SLURM job, using Linux namespaces and Squash Fuse, you can mount the SquashFS. The following is an example batch script that does this. This is great, because now there is only one metadata request for all of your files, not thousands. Remember, SquashFS is read-only. If you need to modify the files, then copy them to JOBFS first. Finally, if you have a complex software environment, then you might want to use Apptainer containers. These bundle software stacks to avoid repeated Lustre reads for libraries. Let's build and run one. For example, we're going to build a container for a Python environment that's used for Bilby, which is a popular gravitational wave analysis code. In this example, we use Mamba to build a Python environment for Python version 3.10 with Bilby and GWPy and a few other Python libraries. We can build the image using the Apptainer build command, which creates the CIF file. The CIF file is a single file that contains our entire software environment. Let's verify that we're actually in the new environment using a simple Python script that prints the Python version. You can see that when we run the script using the Apptainer container that we just built, Python version is 3.10, whereas when we run it normally, we are just using the system Python, which in this case happens to be 3.9. Much like SquashFS, Apptainer containers are read-only. You can use bind mounts to access data on the Lustre file system at runtime. Here is a SLURM job script that puts it all together. In this job, we first load the Apptainer module to make the command available, and then we do an Apptainer run, binding the thread OZ000 directory, which makes the files in that directory available to the software. We're running the bilby.cif image that we made earlier, and then within that image, we're going to execute the Python command and run myscript.py. For maximum speed in I/O-intensive applications, you might want to combine these tools. You can bundle inputs using SquashFS, stage intermediate files on JOBFS, and if you have a really complex software environment, then you might want to use Apptainer. This cuts down on the metadata load, the network traffic, and hopefully the runtime of your job as well. This has just been a brief overview of the strategies you can use, but if you want to implement these yourself, we highly recommend checking out the OzSTAR documentation. Good luck! And if you would like a hand, please feel free to contact us at our help desk.